Okay, alright. So kita continue dengan dimension. Okay, so dimension of physical quantities. Alright, so the important thing about dimension, first thing first, you have to know that. Okay, so this is the basic quantity. Okay, contohnya kita ada mass. Alright, so we put square bracket over there. It shows that we want to do the dimensional analysis. Alright, and the symbol for the basic unit is m. Okay, so it means you also can use square of m. Alright, and the symbol for dimension for mass is capital M. Alright, and the unit for mass is kg. Alright, so this one you have to make sure that you don't get confused with the symbol. Okay, so ada dua symbol dekat sini. Satu symbol untuk basic quantity tersebut, satu lagi adalah symbol untuk dimension. Alright, contohnya you have time. Okay, so the basic unit is time. So you can write full time, or you can just use symbol time is small t. Okay, alright. And the symbol for dimension for time is capital T. And the unit for time is second. Right, now so ada banyak symbol kat sini. You have to make sure you memorize everything. Okay, so please refer to the lecture note. You'll see the table, okay, shows the basic quantity, and then the symbol for dimension, and the next one is the unit. All right. Okay. So, what is the purpose of dimensional analysis? Okay, so ada tiga tugas penting dia lah. Right. So, yang pertama is to determine the unit of physical quantities. Okay, so we want to find what is the unit of the physical quantity. Okay, so we can use the dimensional analysis to check the unit. Okay, number two, the purpose of dimensional analysis is to check whether a physical equation is dimensionally correct, okay, or not, by using the principle of homogeneity. Okay, so kita nak cari whether it's dimensionally correct. Alright, and we're gonna use a principle of homogeneity. So what is the principle of homogeneity? So dia adalah dimensionally correct if left hand side of the equation is equals with right hand side of the equation. Okay, so soalan ni pun biasa keluar, dia minta awak buktikan sama ada dia dimensionally correct or not. Okay, macam mana nak buktikan? You have to check, okay, left hand side dia punya dimension sama dengan right hand side. Okay, alright. And the next one is to derive physical equation. Okay, tapi ini jaranglah keluar soalan. Okay, alright. Okay, so now we have we know already the purpose. Okay, the purpose of dimensional analysis. Okay, next, sebelum kita boleh buat latihan dia, we have to know the condition, right? Ataupun how to perform the dimensional analysis. Okay, so the first one, okay, the first one is if you have a constant number, for example, you have pi in the equation, or you have numbers like 1, 2, 3, okay, so the dimension of the constant number, for example 2 over here, is equals to 1. Okay, so automatically when you put the dimension over there, so you akan dapat equals to 1 lah. Dimension of dimensional constant is 1. Okay, and the second one, dimension cannot be added or subtract. Cannot be added or subtract. Okay, apa maksud cannot be added or subtract? It means that when you have the equation yang ada symbol plus and minus, kita akan abaikan plus and minus tersebut. Tak apa, saya akan tunjuk dalam contoh nanti lebih jelas lah. Okay, and the next one, the validity of equation cannot be determined by dimensional analysis, and validity of equation can only be determined by the experiment. Okay, so jangan gunakan dimensional analysis untuk check validity of the equation. Okay, so yang ni sekadar info sajalah. Alright, okay, so let's try to do one question. Okay, so let's say you have velocity. Okay, velocity. And you want to check what is the unit for velocity. Okay, kita assume lah kita tak tahu unit velocity ni apa. Alright, so first thing you have to know what is the equation of velocity. Okay, so velocity is basically is a change in displacement. Okay, divided by time interval. Alright, okay, so by equation you also can write. Okay, so kita nak gunakan simbol quantity tersebut. Okay, untuk memudahkan lah, tak panjang sangat. So square bracket of V. So we have to put dimension of delta S. Okay, over delta T. Okay, alright, so over here, delta means change of displacement. It means S2 minus S1. And delta T is the same thing, T2 minus T1. Okay, so even though we have a negative minus inside the equation, so kita akan assume sebagai tak ada sahaja, and we just take one unit that, one quantity that we have there. Okay, so square dimension of S, what we're gonna have is L. Okay, symbol dimension for S is displacement. So kita ada L divided by capital T. Okay, seperti yang saya tunjuk tadi lah. Alright, over here. Okay, so dimension of time is capital T. Alright, so what we have now is LT -1. And then we convert into the unit. So daripada symbol dimension tadi, so L the unit is meter and T the unit is second. Alright. Okay, so dekat sini tak boleh letak sama dengan kena letak. So therefore the SI unit for velocity is ms -1. Okay, alright. Okay, another example. Okay, let's say you want to check what is the equation, what is the unit for force. Okay, so force. So we want to find the dimension of force. So saya terus gunakan simbol dekat sini. So we have capital F. Alright, so dimension of force is equals with the equation of F is equals to MA. So letaklah equation dulu. Right, so it means we have to find the dimension of mass and also acceleration. Okay, alright, so now dimension of M, saya letak lagi dekat situ because acceleration is not a basic quantity. A is equals with V over T. Okay, so A, kita cari dulu kat sini ya. A equals to V over T. Alright, and V, this one, V, is S over T. So after all, what we're gonna have over here is S over T square. Alright, so it means that what we're gonna have over here is square bracket of S, okay, over square bracket of T square. Okay, alright, so over here baru kita keluarkan simbol dekat sini. So what we're gonna have, okay, the dimension for M over here is capital M. Okay, kita check balik tadi dekat sini kita ada mass the symbol, the dimension symbol is capital M. So we put capital M over here. As tadi adalah length. So kita letakkan length over. This one we have T square. Okay. So it means that the dimension that you have is M L T negative 2. Right. So therefore, the SI unit for force is, so kat sini kita ada M unit dia adalah kg, L unit ni adalah M, and then T the unit is S negative 2. So you have kg, M, S negative 2. So after all, the SI unit yang kita akan dapat semuanya dalam bentuk basic quantity. Alright. Okay, the second purpose of the dimensional analysis is to check whether the equation is dimensionally correct, or we call it as homogeneous, or dimensionally incorrect ataupun not homogeneous. Okay, saya tuliskan dekat sini. Okay, kalau dia dimensionally correct, means homogeneous. Okay, so apa maksud dimensionally correct? Left hand side must equals with right hand side. Okay, alright. But you are considered to have dimensionally incorrect, ataupun nama lain dia kita panggil not homogeneous. When you have left hand side not equal with right hand side. Okay. So let's look at one example. Okay, let's say you have equation. Okay, so example 2s equals with 2ut plus at square. Okay, so you ada equation ni. So kita dah biasa sebenarnya tengok equation ni. So we want to check whether this expression are dimensionally correct or not. Okay, maksudnya nak tentukan dia sama ada homogeneous or not homogeneous. Okay, so what we have to do is, okay, so you can find one by one, or you can just do it side by side. Okay, tapi saya this one saya prefer untuk buat satu persatu supaya nampak jelas. Okay, so left hand side, okay, yang kita ada dekat sini adalah 2s. Okay, so we want to check what is the dimension for 2s. Alright, so this one, it means you're gonna have dimension of 2, dimension of s. Okay, so previously we already know that dimension of constant number equals to 1. So tak perlu tulis lah. Okay, 1 dekat sini. And then dimension of s, displacement is L. Okay, so you dah ada left hand side, the dimension is L. Okay, right hand side, what you're gonna have is the equation 2ut. Okay, because of we have plus over here, kita akan buat satu persatu. It means right hand side you ada dua equation. Okay, so kita akan buat 2ut dahulu. So again you're gonna have dimension of 2, dimension of u, and then dimension of t. Alright. Okay, so what you're gonna have over here, so dimension of 2 equals to 1. So tak perlu tulis. Dimension of u is initial velocity. So tadi kita dah buat dah. Initial velocity, we have LT negative 1. Okay, and then dimension of t is t. Okay, so after all, what we're gonna have over here is L. Right, so another terms for right hand side, what we have is AT square. Okay, so again, dimension of A, dimension of T square. Okay, so over here what you're gonna have, tadi kita dah buat juga yang acceleration tadi, what we're gonna have is LT negative 2, okay, times with T square over here. So you have T negative 2 and this one T power of 2, so you boleh cancel lah this one. So after all what you're gonna have is L. Okay, sama dekat sini tadi tu boleh cancel. Alright, so it shows that the right hand side, the left hand side of the equation, is equal with the right hand side. Okay, dia mesti dua-dua sama. Kalau ada dua terms dekat sini, so dua-dua mesti sama. Okay, untuk right hand side, 2ut and also at square. Alright, so when you have left hand side equals to right hand side, it means this equation is homogeneous. Okay, alright, so nampak dah dekat sini bila ada plus ke minus ke simbol dekat tengah ni, macam mana kita nak treat dia. Kita akan anggap dia seperti tak ada lah dekat situ, kita tak ada pun tambahkan equation, tak ada. Okay, tambah ataupun tolakkan equation, hanya darab dan bahagi sahaja yang terlibat. Okay, alright, so that's all for dimensional analysis. Thank you.